All right, let's get started with 12.3 tangent line problems. So in this section, we're going to start really getting into some calculus. And so calculus, we're talking about rates of change. All right, lots and lots of rates of change problems in calculus. So, all right, earlier in the text, and I mean way earlier, like the very beginning, we learned the slope of a line indicates the rate at which a line rises or falls, right? A positive slope is going up. A negative slope is a line that's going down, all right? And then this one right here, that's a slope of 0, right? If we have a flat line, okay? So we also know, we can think back to some Algebra 2 stuff, that we have a tangent line. Tangent line is the line that just barely touches our curve, all right? And so a tangent line is going to approximate the slope of the graph. So if we can figure out what the slope of the tangent line is, we can approximate the slope at a specific point. All right, so problem 1, example 1, we're just going to use a visual approximation to figure out what's the slope of the graph of f of x equals x squared at 1, 1. All right, so we've got this tangent line here, and just visually, we're going to go over 1 and up 2. So if we think back to slope, rise over run, we rise 2, we run 1, our slope is 2. All right? So for the first problem, that's all we're doing. Go ahead and do that same sort of thinking on exercise 5. Okay, same exact type of thing here on example 2. What is the slope of the graph at 10, 69 here? All right, so we can look at our tangent line here, and we can see that we are rising negative 16. This is going down. Running 2, so negative 16 over 2 is negative 8. And this one does say give an interpretation. So this is going to be degrees, negative 8 degrees per month when we give the interpretation. All right, your turn again, problem 7. Okay, so in examples 1 and 2, we kind of just eyeballed them, right, to see what the lines are. So the slope of the line. More precise, and we want to be more precise here, we're going to use a secant line. So if we think back to geometry, we remember a secant line is a line that connects 2 points on a curve. All right? And so what we're going to do here, if we wanted to find the slope of the secant line, we could do that because we have 2 points, an x and a y, and an x and a y. We could figure out the slope because remember the slope is the change in y, this is f is the y value, divided by the change in x. And we're going to use the letter h to denote the change in x here. Now, if we moved our secant line closer and closer and closer in until eventually it became the tangent line, we would get the tangent line. So what we're saying here is we're going to make the secant line shorter and shorter and shorter. That's the same thing as finding the limit as h approaches 0. The limit as the distance in x becomes smaller and smaller and smaller. So the slope of a graph, we can write it down right here. It's the limit as h approaches 0 of the, what is this? Look at this. This should look very, very familiar. This is the difference quotient. We've seen this a whole lot. So the slope of a graph at a certain point x is defined as the limit as h approaches 0 of the difference quotient. All right? So we're going to use this in a couple different problems here. So let's find the slope here of f of x equals x squared at the point negative 2, 4. So limit as h approaches 0 of f of x minus h plus h minus f of x all over h. All right, let's plug this in. Our function is x squared. Our x value is negative 2. So we're going to say negative 2 plus h squared minus negative 2 squared. I'm using negative 2 for x. We know that x is negative 2 all over h. Let's clean this up. Negative 2 plus h is going to be 4 minus 4h plus h squared minus 4 all over the h. 4's go away. And so let me rewrite this as h squared minus 4h all over h. Pulling h out, we've got h minus 4 all over h. Let's cancel the h's. And so we've got, remember it was the limit as h approaches 0 all the way through. We just weren't writing it, of h minus 4. What's 0 minus 4? We can do direct substitution. The slope is negative 4. All right, at negative 2 comma 4. You can see we've got a graph here. Let me erase this so we can see it. When we're at negative 4, the tangent line here is going down, so the slope would be negative 4. If we were over here, the slope would be positive. We're going back up when we're over here, so it's specific to that point. All right, so use those steps. Try exercise 9. All right, so now we're going to do example 4. They're not going to give us an x value. We're going to come up with a formula instead of an exact slope for a point. So same steps here. Let's do the difference quotient. So we're going to go negative 2. Instead of x, we're using x plus h plus 4. That's our first part. Minus f of x, which is just negative 2x plus 4. And this is all going to be over h. Let's clean this up. So we've got negative 2x minus 2h plus 4 plus 2x minus 4 all over h. What cancels? U cancel, and U cancel. We've got negative 2h over h, which is negative 2. The limit as h approaches 0 of negative 2 is just negative 2. So that's going to be the slope of this. No matter where we go, the slope is negative 2. All right, so we can see the graph here. It's a straight line here, so the slope's going to be the same no matter where we are on this graph. All right, you're up. Exercise 11. All right, so I just said this, but this is reinforced in the book. Notice the difference between 3 and 4. 3 and 4 was finding a specific slope at a specific point, right? Versus example 4, we found a general formula for the slope. So make a point of the distinction between those two things. All right, moving on, find a formula for the slope of the graph here, and then what are the slopes at the 2 points. So the reason we're going to find the general form first is that then we can just plug x values straight in. So let's find the general form first. X plus h squared plus 1 minus x squared plus 1 all over h. We get x squared plus 2xh plus h squared plus 1 minus x squared minus 1 all over h. Let's do some canceling. So we've got 2xh plus h squared over h. Pull an h out, and we're going to have 2x plus h over h. And our h's go away. And so we have the limit as h approaches 0 of 2x plus h. That's just 2x. So our slope is going to be 2x. So now we can go here. What's the slope at this point? It's going to be 2 times negative 1. 2 times x. So that's going to be negative 2. What's the slope at this point? It's going to be 2 times the x value times 2. So the slope there is going to be 4. All right, so we found the general formula, and then we were able to plug in specific x values. So you're going to do the same thing here for exercise 17. All right, we're going to wrap up with 2 examples here with just some vocab changes. the word derivative is going to be introduced here, and derivative means the same thing as what's the slope at a point. All right? So derivative is just another way of saying it, but we can also say f prime of x. That's the symbol for doing derivative, and we're just doing the exact same thing. So let's do a couple examples here just to reinforce this. Find the derivative of this. We're doing the same thing. We're doing the difference quotient. 3x plus h squared minus 2x plus h minus 3x squared minus 2x. This is all over h. And so we've got 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. Let's do some canceling. Minus 2x and plus 2x. Minus 3x squared and plus 3x squared. And what do we got left here? Anything left? Nope, nothing else will cancel. So 6xh plus 3h squared minus 2h all over h. Let's pull an h out front. 6x plus 3h minus 2 all over h. Go away. And so we have the limit as h approaches 0 of 6x plus 3h minus 2, which is 6x minus 2. Okay? All right, so that is the derivative of that function. Your turn on 33. Find the derivative of 4 minus 3x squared. And last one here, last example, we're going to find the derivative of the square root of x, then find the slopes at 1, 1 and 4, 2. So we're finding f prime of x, which means the same thing as the derivative. So square root of x plus h minus square root of x all over h. And let's use our old friend the conjugate here. And so we're going to end up with x plus h minus x all over h, square root of x plus h plus square root of x. And so x minus x goes away, h is canceled. We're left with the limit as h approaches 0 of 1 over square root of x plus h plus square root of x, which is 1 over square root of x plus square root of x, which is 1 over 2 root x, which is root x over 2x. There we go. That's our derivative. That's f prime of x. And so if we plug in 1, we're going to have square root of 1 over 2 times 1, which is 1/2. And if we plug in 4, we're going to have the square root of 4 over 2 times 4, which is 2 over 8, which is 1/4. All right, there it is. You've got one left to do. Knock out problem 43. Any questions, we'll go over them in class.